What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Security Plus 601 certification exam. So let's get into it. In this video, you're going to learn about various biometric authentication methods such as fingerprint scans, retina scans, iris scans, facial scans, voice recognition, finger vein biometrics, gait analysis, efficacy rates, false acceptance ratio, false rejection, and crossover error rates. Biometrics, these are body measurements and calculations related to human characteristics. Biometric authentication, also known as realistic authentication, this is used in computer science as a form of identification and access control. Biometric identifiers are the distinctive, measurable characteristics used to label and describe individuals. Biometric identifiers are often characterized as physiological characteristics, which are related to the shape of the body. Behavioral characteristics are related to the pattern of behavior of a person, including but not limited to typing rhythm, gait, signature, behavioral profiling, and voice. Since biometric identifiers are unique to individuals, they are more reliable in verifying identity than token and knowledge-based methods. However, the collection of biometric identifiers raises privacy concerns about the ultimate use of this information. And the types of biometric authentication methods that you need to know to pass the Security Plus 601 exam are as follows. You need to know about fingerprint scans. So fingerprint authentication, this automatically compares a user's fingerprint to a stored fingerprint template in order to validate a user's identity. Because we are all born with unique fingerprints, fingerprint scans are an inherence factor or something you are, making them impossible to guess and difficult to alter or fake. Next, we have a retina scan, and this is a biometric technique that uses unique patterns on a person's retina blood vessels. The human retina is a thin tissue made up of neural cells that is located in the posterior portion of the eye. Because of the complex structure of the capillaries that supply the retina with blood, each person's retina is unique, making retinal scans an emerging authentication method. Next, we have an iris scan. So iris recognition, this is an automated method of biometric identification that uses mathematical pattern recognition techniques on video images of one or both of the irises of the individual's eyes, whose complex patterns are unique, stable, and can be seen from some distance. Digital templates encoded from these patterns by mathematical and statistical algorithms allow the identification of an individual or someone pretending to be that individual. Next, we have facial recognition. So a facial recognition system, this is a technology capable of matching a human face from a digital image or a video frame against a database of faces, typically employed to authenticate users through ID verification systems. They also work by pinpointing and measuring facial features from a given image. Next, we have voice biometrics, and this is a technology that relies on the recognition of voice patterns to verify the identity of individuals. This is possible because each person's vocal tract is unique. Physical features, both phonetic and morphological, are particular to each individual, making them virtually fraud-proof. As a result, voice recognition technologies enable a higher level of security than other identification systems, such as PIN-based systems. Next, we have vein biometrics. So finger vein biometrics is also called vein matching or vascular technology. This is a technique for biometric authentication that analyzes the patterns of blood vessels visible from the surface of the skin of fingers. This technique relies on capturing images of the veins inside of one's hand by shining near-infrared light on the fingers. This makes it almost impossible to counterfeit. In addition, blood flow in the veins during identification ensures that the individual is alive and real rather than a fraudster. Next, we have gait analysis. So gait recognition, this is an indicator that is used in behavioral biometrics to identify a person over a long distance without direct contact. When a person walks, it is possible to observe around 24 individual parameters and movements that form the uniqueness of the gait. Gait biometric systems capture step patterns using video images and then convert the data into a mathematical equation. Gait as a biometric measure can be influenced by several factors, including footwear, terrain, fatigue, and injury. Next, we have efficacy rates. So efficacy rates vary depending on the technology. As newer and more accurate methods for using biometrics as an identity provider expand, so do the efficacy rates. For example, certain eye diseases and metabolic conditions can reduce or negate the efficacy of an eye or iris scan. Veins might not be as pronounced in certain people with different types of skin or skin diseases, and social and cultural considerations must also be taken into consideration because some people might not like touching devices in fear of contracting diseases. Then you have false acceptance. So the false acceptance ratio, this is a unit used to measure the average number of false acceptances within the biometric security system. It measures and evaluates the efficiency and accuracy of a biometric system by determining the rate at which unauthorized or illegitimate users are verified on a particular system. Then you have what is called false rejection. So this occurs when a biometric device rejects a genuine user and incorrectly labels that user as an intruder. The accuracy of a biometric device is judged by its false rejection rate. And then we have the crossover error rate. And the crossover error rate, this describes the point where the false reject rate and the false accept rate are equal. The crossover error rate is also known as the equal error rate. And the crossover error rate describes the overall accuracy of a biometric system. So simply put, the crossover error rate is the percentage at which the false acceptance rate and the false reject rate are equal. All right, so that was my class on biometrics, where we talked about various biometric authentication methods such as fingerprint scans, retina scans, iris scans, facial scans, voice recognition, finger vein biometrics, gait analysis, efficacy rates, false acceptance ratios, false rejection, and crossover error rates. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Security Plus 601 certification exam. And until next video, ladies and gentlemen, peace.